My name is Emily Reif, and I'll be presenting a linguistic lens, visualizing the linguistic diversity of text datasets synthesized by large language models. And of course, this is work I'm presenting on behalf of myself and my collaborators, Minsuk and Savvas. So overall, I'll be talking about synthetic data, why it's important, and what its challenges are. I'll be demoing our tool, talking through a couple use cases, and then leaving some time for a conclusion. So large language models are becoming ubiquitous. ChatGPT, Bard, and they're used for all sorts of things, from end user products to search to a wide range of use cases. One of those use cases is creating synthetic datasets. So these are small curated datasets where that are used for things like benchmarking, fine-tuning, and other small sort of targeted tasks. And this is so exciting because you only need 5 or 10 examples, even fewer than that. You can expand these into much larger data sets that are actually used for reasonable tasks. And this was not possible before. You'd have to, go scrape a data set or have human annotation to individually create each data point. However, like any new technology, it's hard to know if these data sets are good enough. How do you evaluate them? And like large language models, data sets generated with them have different and surprising failure modes. And for example, low diversity and duplication, and especially, fuzzy duplication in surprising ways. So for example, a data set might have a bunch of repeated examples that are very similar to one of the inputs. So maybe they talk about a specific location, or there's some, entity that gets mentioned a few times. But there's also other ways of overfitting. And we're going to look at both of these, but especially at syntactic overfitting. So data points that are phrased very similarly, even if they have different content, which it feels like, in some ways, if it's hard for us to spot, is it a real problem? And the answer is actually yes. You end up with these sort of templated type examples that can be hard to find programmatically and hard to even recognize as a group if they're unordered in your data set, but in fact do lead to very low data set diversity, which has downstream implications. So after talking to a few software engineers and researchers who were trying to generate data sets in this way, we came up with 4 main challenges that they seemed to be facing, or 4 main challenges and things that they wanted to do with these data sets. The first was to get a quick overview, so see sort of what a basic example looks like, what do the seed examples look like, how similar are they, that sort of thing. They also want to identify groups of examples, finding patterns, similar characteristics, that sort of thing. And even farther down this line, find near duplicates. So these are examples that they knew they wanted to delete, but they wanted to, examples that were too similar to each other. Even if they're not exactly the same, they might be the same within some notion of similarity. And finally, in general, they just sort of wanted to understand dataset diversity. This was a term that came up a lot, it's sort of an ambiguous term and meant something different for every practitioner. The general question is the dataset as a whole broad and diverse? Does it cover the range of things that I want, or is it too sort of clumpy is it repeating each of your input data sets a bunch of times, or is it sort of spreading out and feeling like it's actually a diverse data set? So now I'm going to go ahead and jump into a demo. To face these challenges, we created Linguistic Lens, which is a human-in-the-loop tool for understanding linguistic diversity in generated datasets. So here is a picture, here is the UI for Linguistic Lens. And this is a dataset that is musical queries. So things like music that's not too fast, music to write to, danceable indie music, electronica. These are queries that a user might ask of a music recommender system to elicit suggestions or elicit bands or songs. So for Linguistic Lens, and so the initial 10 examples you can see are highlighted in gray, and the rest of the ones that do not have the gray background are generated using a large language model. So there's a pre-processing step where we first cluster the data points. We first calculate the similarity between the data points along a number of axes and a number of different kinds of similarity. For this demo, just for the sake of time, we're going to be mostly focusing on syntactic similarity, but we also look at token similarity and embedding similarity. So you can play with this demo online or see our paper for more details. So once you have this similarity matrix, we then cluster the data points based on this similarity using hierarchical clustering. And so within the clusters, we also see that similar data points are close to each other as well. So this sort of allows the user to get an overall view of like, okay, here's sort of the range of clusters of data points. We have a bunch that sort of have this general shape, some single word ones, etc. Each example is colored by the token's part of speech. So, for example, adjectives are in red, adverbs are in purple, verbs are in orange, etc. The syntax tree is shown in gray to more easily see syntactic structure. And so as I accidentally demonstrated a moment ago, hovering over a single token will pull up other tokens or will highlight other tokens with the same syntactic similarity. So, for example, these are, adverbs that modify adjectives. So too fast, too harsh, isn't too, etc. So you can also, again, sort of see groups of patterns that, might tie a bunch of data sets together, or a bunch of data points together. And as mentioned, Linguistic Lens shows the data sets in clusters in these columns. To get a quick overview of each cluster, we also create a summary with using frequent pattern matching. And so this is done with a heuristic algorithm, and again, see the details in the paper. And it shows a combination of parts of speech and actual tokens. So for this cluster, we see that of the 45 data points, all of them have blah, 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 that verb, blah, 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 blah. And, similarly, of this cluster of 23 data points, 7 times we get music for blank. Or in this one, music for a blank. So it kind of gives you a quick overview of like, okay, what's this data set? What's this cluster sort of about? We also have a collapse mode, which is based on TableLens, adapted from TableLens. And this view shows a thumbprint of the examples, letting the users get sort of a quick overview of linguistic patterns and linguistic diversity across the data set. So we can see that this cluster just has a bunch of data points that are an adjective followed by a noun, whereas there are other sort of more diverse parts of the data set, less diverse parts, gives you sort of a quick glance. So I'm going to dig a little closer into this music queries data use case. There's another use case for dialogue that we delve into in the paper, so check that out as well. So the dataset creator first gets a sort of overview of their dataset, as I was saying, seeing the general shape of the data. And then we see a couple of interesting insights. So for one thing, there are some unexpected clusters that feel a little bit template-y, right? So like good classical music, modern classical music, danceable indie music, old-timey instruments, weird experimental music. Are these overly templated? Are they a problem? Are they just normal, a cluster that would show up in any data set? Not totally clear, but it's not up to us to decide, right? There's no automatic way to figure out whether this is okay or not. This is really something that we should surface to the user and see whether they find it to be overly programmatic or overly repetitious. So, for example, experimental music with the band, classical music for a funeral, new music from the 50s, good music for the gym. These probably are a bit, you can see that while if you saw any individual one of these, they're probably fine. As a cluster, they are sort of templated, and this data set isn't huge, so the fact that there are a bunch of data points with this very similar syntactical tree, it kind of does point to repetition within the data set that should be dealt with either by deleting or adding different data points. Another thing that was another interesting insight that we found with Linguistic Lens is that some repetition actually is desirable, and in fact, we want more of it. So, for example, this bands from the 90s, music from the 1980s, the dataset creator might actually look at that and say, oh, I know that I want it to be equally likely to say 80s, 90s, 70s, 60s, whatever. So maybe I want to take this cluster and create even more duplication. So, specifically add data points that are bands from the 90s, bands from the 80s, bands from the 60s, the 70s, etc. And what's cool is that now that we have synthetic data, we can actually, we have LLMs that can help us create synthetic data. I mean, that's not the only way, but one way. We actually can think of data sets themselves as these sort of malleable, both objects that we can observe and create, and so iteratively try to better and make sense of. So just in the interest of time, I'll wrap up, but I'll just say that evaluating synthetic data brings new challenges that are not currently well supported. We present a human-in-the-loop tool to better understand diversity and overfitting in synthetic data. And we would love to hear from you. So please contact us, Emily Kahng or Petridis at google.com.